going to follow a process when we're doing these hypotheses testing. And I like to break this down into 4 steps. Some textbooks have more or less, but this seems to work for the way that I think about hypothesis testing. So the first thing that you need to do is assume that the null hypothesis is true. Then you're going to determine the likelihood of observing the data in your sample if the null was true. And we're going to use the normal distribution here, that sampling distribution. And so how would we decide if the value of our sample is likely? Well, we're going to make some claim. So we're going to assume that this null value for the proportion is the value for the population proportion. Now, we're going to go and we're going to collect a sample statistic. Now, anything that's within 2 standard deviations is probably pretty likely. So if we were to get anything in that range, these would be likely. You wouldn't be surprised that you ended up with a value there. And so if you get something that is in that likely region, then you are not going to reject your null. But let's say that we have our distribution, we make some assumption of what that true p-value is, and then we end up with something far away. If we get something far away, these tails, these would be unlikely values to happen if our null hypothesis were true. And that is the theory behind what's going on. We're going to determine which values are likely values and which values are unlikely values. And we're going to do that by using the normal distribution and calculating the probabilities under these sampling distributions. So you have 2 choices after you calculate these likelihoods. If your data is unlikely, if you end up with something in the tails, well, that was based on assuming that null hypothesis value, and we didn't get something likely, so that null value is probably not true. And so we're going to do what's called rejecting the null in favor of that alternative. Now, if your data is not unlikely, so if you found things that were in that likely region, then you don't have any reason to suspect that that null value is incorrect. So what you'll do here is you'll fail to reject. Now, it's important here to note that we aren't accepting anything. We're not accepting the null. We're not saying without a shadow of a doubt that that's the value, because it might be some other value that's close to it. But the idea here is that we don't have enough evidence to suggest that it's anything other than what we assumed. So that's going to take a little bit of work on your part to try to figure out why this process works the way that it does. And you'll get there as we do examples, as you read through the textbook, and as you listen to these explanations. You'll start to understand the logic here, but it definitely is a very subtle and not intuitive approach at first. But once you get used to it, then it'll just feel super comfortable to you. You're always going to start by writing the null and the alternative hypothesis. So your null will always be something like this. Your population characteristic is equal to some hypothesized value. Then your alternative will always have one of 3 forms. You'll either think that the population characteristic is greater than that hypothesis or hypothesized value, less than the hypothesized value, or just not equal to. I'm going to do a little bit of shorthand here. You'll pick one of these 3. You won't use all of them. You'll just pick one. What do you think is going on? Do you think it's greater than, less than, or just not equal to? So let's take a look at example 10. Here we're looking to see we're interested in determining if the sample of 18 to 34-year-olds support the claim that fewer than 1/3 of adults in this age group live with their parents. So what are we looking for? What is P? What is the population characteristic that we want to know? Well, we want to know the proportion of 18 to 34-year-olds who live with their who live with their parents. Want to write our hypotheses about what we think is going on in this example. So our null, whoops, that was the eraser. So our null, H0, is that the proportion is 1/3. Okay, we're looking at this claim that fewer than 1/3 of adults live with their parents, and so we need to start with the assumption that it is 1/3. But our alternative, what we think might be happening, is that it's actually less than 1/3. So our null will always be equal to some hypothesized value, and then the alternative will always be some comparison other than equal, so greater than, less than, or not equal to that same value. So notice two important things here. Actually 3 important things. I'm dealing with P, the population proportion. That's what I'm hypothesizing about. I have equal in the null, and then the other in the alternative. And then I'm using the same value for my comparisons. I'm using nothing about any sample data right now. And that's one of the biggest mistakes that students make, is they try to put sample data into these hypotheses, and it has nothing to do with the sample when you're writing your hypothesis. Now let's look at example 2. We have a survey of 1,012 Americans, and we're looking to see if they think they're in better financial shape than they were a year ago. So suppose we want to determine if the survey data provide convincing evidence that a majority of adult Americans believe they are in better financial shape. So what is P? What do we want to know? Well, we want to know the proportion of adult Americans who believe they are in better financial shape. Skipped ahead. If you need to pause the video and write that down, this would be a good time to hit pause. But then we need to state our hypotheses. So what does it mean for something to be a majority? Well, that's simply more than half. So we're going to first start by assuming that it's just half, 0.5, and then our alternative is that we think it's a majority, so we think it's greater than 0.5. For a lot of students, the hardest part is just getting these hypotheses translated from the English words in the examples. Now let's do one more here. The manufacturer of M&Ms claimed that 40% of plain M&Ms are brown. A sample of M&Ms will be used to determine if the population proportion of brown M&Ms is different from what the manufacturer claims. So P here is just going to be the proportion of M&Ms that are brown. And then what are the hypotheses? Our null is that it's exactly what the manufacturer says. It's 40% or 0.4. And the alternative is that we think maybe it's just something different. So that would be not equal to. Now, when we were talking about the logic here, this process, we determined if our sample value fell into the likely region or the unlikely region under the assumption that the null hypothesis was actually true. But we see in this distribution that sometimes it is part of that distribution. We just happen to get a really small value or a really large value from the population. So it is possible for us to draw the wrong conclusion about the population when our sample is in those tail values. It's also possible that if we had some other distribution that this came from, let's say that we had some distribution, it's way over here. Well, wouldn't it be possible that we get something that is in the tail of this distribution? And so we end up with a value that we think is likely, but really the true population proportion was something different. See, we don't know what the population proportion is, and so sometimes we're going to make some errors just because sampling is not perfect. So the types of errors that you might make are a type 1 or a type 2 error. So a type 1 error happens when you have rejected the null, when the null was actually true. A type 2 error is when you have not rejected the null, you have failed to reject the null, but the null was actually false, so you should have rejected it. And the problem with these errors is you really don't know that you've done it. And that's the scary thing. And that's how sometimes drugs make it to market when they aren't safe, or sometimes they're not effective. Because sometimes in your clinical trials, you have something that seems to be effective or seems to be safe based on your sample, but then when you deploy it for the entire population, that's not true. So the problem with hypothesis testing is that you could be making errors and you don't always know that that has happened.